Lake Baikal, located in the mountainous region of Siberia, in Russia, is not simply a body of water. It is a geological and biological monument that challenges our understanding of the natural world. Known as the Blue Eye of Siberia, this body of water is the oldest and deepest on the planet, holding approximately 20% of Earth's unfrozen freshwater. However, what a submarine recorded in its depths during the expeditions of 2008 surprised everyone, not only because of what was seen through the hatches, but also because of the magnitude of the technical feat and the scientific mysteries that began to be revealed. Leave a like, subscribe, and share. Let's begin. The Russian expedition of 2008 was designed as one of the most ambitious freshwater exploration missions in history. Using the Mir-manned submersibles A and Mir-B, famous worldwide for their participation in the exploration of the Titanic and in the placement of a Russian flag on the bottom of the Arctic, the scientists set out to reach the bottom of Lake Baikal. The objective was twofold: to break freshwater depth records and to conduct a comprehensive study of an ecosystem that has evolved in isolation for more than 25 million years. Each submersible carried 3 people who ventured into a darkness that few human beings have witnessed. What initially caused massive surprise in the media around the world was the report that a record depth had been reached. In the heat of the mission, it was reported that the submarines had reached the 1,680 meters deep, which was immediately interpreted as an official world record for freshwater dives. However, the reality of scientific exploration is often more complex than the headlines suggest. Shortly after the announcement, denials and clarifications emerged. Although the Mir-A and Mir-B had indeed reached the bed of the deepest lake in the world, the exact measurement and international protocols led to a rectification regarding the record category. This initial confusion did not detract from the achievement, but rather highlighted how difficult it is to operate in an environment where water pressure is overwhelming and geographical conditions are extreme. As the submersibles descended, the visibility in Lake Baikal left the researchers astonished. Due to the purity of the water and the presence of specialized microorganisms that filter the sediments, Lake Baikal has a legendary transparency. Even at considerable depths, the lights from the Mir revealed an underwater landscape that looked like it was from another world. Instead of an aquatic desert, scientists found a rich biodiversity adapted to extreme pressure and constant temperatures close to freezing. They saw endemic species, such as the small Epicura crustacean, responsible for cleaning the water, and deep-sea fish that appear translucent under the beam of light from submarines. This unique ecosystem is what makes Lake Baikal a living laboratory. More than 80% of the species that inhabit its depths are found nowhere else on the planet. The expedition allowed for a close observation of the lakebed structure, where hydrothermal sources emit minerals that support chemosynthetic life forms. This finding is fundamental to understanding how life can thrive in conditions of absolute darkness, offering clues about how life could exist on icy moons of other solar systems, such as Europa or Enceladus. But the importance of Lake Baikal goes beyond biology. The lake has become a crucial setting for cutting-edge physics. Thanks to the transparency of its waters and its depth, international scientists have installed Neutrino telescopes in its abysses. The Baikal GVD project is a giant network of sensors designed to detect neutrinos, almost massless subatomic particles that travel through matter without interacting with it. The lake water acts as a natural filter against other radiation, allowing the sensors to capture the subtle flash of light, known as Cherenkov radiation, which occurs when a neutrino interacts with a water atom. Thus, what began as a search for depth has transformed into a window to the cosmos, seeking answers about the origin of the universe from the bottom of a Siberian lake. Despite the scientific rigor of the missions of 2008, Lake Baikal has always been surrounded by an atmosphere of mystery and folklore that the expedition could not completely ignore. The local inhabitants, the Buryats, have passed down for centuries legends about giant creatures that inhabit the abyss. They speak of the Lord of the Water Dragon, or of a colossal serpent that guards the treasures of the lake. Although the Mir submersibles did not record any prehistoric monsters, the vastness of the place fuels the imagination. The most unsettling mystery, however, comes not from ancient legends, but from modern military reports. In 1982, during training exercises for Soviet military divers in Lake Baikal, an encounter was reported that still sparks debate in ufology and mystery circles today. According to reports, the divers were found about 50 meters deep, with humanoid beings of approximately 3 meters high. These beings wore tight-fitting silver suits and spherical helmets, but they did not carry oxygen tanks or conventional diving equipment. The incident ended in tragedy when military divers attempted to capture one of the creatures with a net. An unknown force propelled them to the surface, causing severe decompression sickness that resulted in the death of 3 of them and serious injuries in the rest. Although the expedition of 2008 found no trace of these swimmers, the record of such anomalies adds a layer of intrigue to any incursion into its waters. The geological complexity of Lake Baikal is another of the surprises that the submarines confirmed. The lake is located in an active rift zone, which means that the Earth's crust is slowly pulling apart at that point. Unlike other lakes that fill with sediment and die over millennia, Lake Baikal is expanding. Some geologists suggest that we are witnessing the birth of a new ocean. The mere documented cracks and rock formations that provide evidence of this incessant tectonic activity, which explains why the lake is so deep and why its bottom remains a constantly changing territory. Leave a like, subscribe, and share. The expedition also served to raise awareness about the fragility of this paradise. Despite its isolation, Lake Baikal is not immune to human activity. Submersible records showed that, although the seabed appears pristine, there are legitimate concerns about the impact of climate change and nearby industrial pollution. The preservation of this ecosystem is vital, not only for its beauty, but because Lake Baikal contains the world's largest deposit of liquid fresh water, a resource that will become increasingly valuable in the centuries to come. The success of the Mir submarines A and Mir B lay in its ability to demonstrate that human technology can reach the most remote places on our planet to extract knowledge. The surprise it caused in the public was not only because of the records, but because of the realization that there are still frontiers on Earth that are as unknown as outer space. Lake Baikal is a mirror that reflects our curiosity and our capacity for wonder. Every time a camera descends into its depths, it reminds us that reality often surpasses fiction, whether through the detection of invisible particles coming from distant galaxies or by observing a transparent fish that has swum in those waters since before modern humanity existed. In conclusion, what the submarines recorded in Lake Baikal in 2008 was the beginning of a new era of discoveries. The denial of the official world record was a minor detail compared to the wealth of biological, geological, and physical data obtained. Lake Baikal remains a silent giant that holds secrets about the evolution of life and the mysteries of the universe. Whether through the rigorous science of neutrino telescopes or the haunting tales of unexplained encounters, this Siberian lake remains a reminder that our planet is a vast, deep place full of surprises waiting to be understood. The exploration of Lake Baikal is not over. We are only scratching the surface of what this freshwater sanctuary has to tell us. The importance of the Mir Expedition A and Mir B also resides in Russian national pride and international cooperation. These vehicles, symbols of Soviet and Russian engineering, proved that they remain top-level tools for global science. The fact that 3 people could be seated more than 1,600 meters below the surface of a Siberian lake, directly observing life at the bottom, is a testament to human courage. The recordings obtained have served to educate new generations of scientists about the need to protect these biodiversity hotspots. As long as the neutrino telescopes installed at the bottom continue to detect signals from deep space, Baikal will be a bridge between the deepest parts of the Earth and the farthest reaches of the sky. Legends of giant creatures and humanoid beings will continue to circulate, adding a veil of romanticism and fear to its dark waters. But it will be science that ultimately determines what is true in the shadows. The submarine's record in Lake Baikal surprised us all because it showed us a world that, although it is on our own planet, is governed by its own rules of time, pressure, and light. As the global climate changes, monitoring Lake Baikal becomes an absolute priority. Future expeditions will likely use more sophisticated autonomous robots, but the mission of 2008 will always be remembered as the moment we put human eyes on the lowest point of the largest freshwater reservoir on Earth. It was a moment of technical validation and spiritual discovery, where the immensity of the Siberian abyss met man's tireless curiosity. Lake Baikal is not just a lake. It is a sanctuary of the unknown, a geological time capsule, and a beacon of scientific research that will continue to surprise us with every dive. The incredible visibility reported by the Mir crew allowed for detailed mapping of areas that had never been seen before. This cartographic detail is essential to understanding how sediments move and how nutrients are distributed. Sustaining the Baikal seal, the lake's only mammal, and the vast populations of amalfish. Water transparency is not just a visual phenomenon, but an indicator of the ecological health of the system. If the water were to lose that clarity, the impact on endemic life and physics experiments would be catastrophic. The legacy of the Russian expeditions to the bottom of Lake Baikal is a call to humility. Given the record depth and age of the lake, our disputes over world records seem insignificant. What really matters is what we learn about the resilience of life and the workings of our world. Lake Baikal is still there, with its 1,680 meters deep, its neutrino telescopes and its legends, waiting for technology and human courage to come together again to decipher the next chapter of its never-ending story. Leave a like, subscribe, and share. See you next time.